Let's do a quick recap what we did for week 7, what we are doing for week 7. I've already told you it's going to be numerical data, right? Numerical data. So numerical data means data involving numbers. We can really go out there and measure them. For example, salary, GPA points, or maybe mileage, those other things as well. Okay, great. And hopefully you have already prepared. You have a copy of the handouts with you. I'm going to do a screen share. So we're going to talk about 2 different kind of tests here, and they are sort of related. Okay. So what we are dealing for module 7 is we are dealing with multiple population. You may remember what we did before the midterm was single population. And after midterm, we move on to multiple populations. For week 5, week 6, we were talking about 2 and now maybe 3 and beyond populations, but those are for categorical data. And right now we're dealing with numerical data. We're gonna start thinking, how about if we have 2 populations? And then next week, we're going to talk about 3 and beyond. So they are not going to be the same type of test as what we did before. And I'm going to give you several examples. Sometimes I also give you the explanation why we are doing this, right? Okay, so for this week, we are dealing with 2 populations, only 2. Okay, so the 2 different kinds of tests we are talking about here in this week. So the first one is called 2-sample test. Okay, and then the next one is called a paired test. Okay, so let's take a look. So so we are dealing with numerical data. So this is a very important numerical data. And the kind of problems we are dealing with is mostly about mean problems. So I'm going to write down here is a mu. Okay, it's a mean problems. Okay, so it could be a z-test. It could also be a t-test. And if you have ever watched the video, you probably know there are some different ways to distinguish them and how we determine which test to use. Okay. And so there's a bunch of formulas which are going to be involved for two sample tests. It could be pair or maybe independent test. And so the formulas are all posted on Canvas. I'm just going to give you remind you that. Okay, so they're all here. I'm doing a screen share. So this is a 4-page document. This is going to be the one that's provided to you during the final exam. So you don't have to write anything that's coming from this table. You don't have to do that. Okay, so it's 4 pages. The first page is about categorical data. So this is what we did for module 5. And so if you go to the next one, this is the second page. This is the numerical data. And again, the next one is also numerical data as well, right? So you can see. So all the formulas we are the very last page is also as well, except this one is hypothesis testing, but previously was estimation. That means we are dealing with confidence interval. So those are all confidence interval problem, CI problem, confidence interval. Okay, and so all the formulas are here, and you don't have to memorize them. And so hopefully you are able to see there's a very standard pattern of how we are dealing with this question. They are very, very much related, right? Okay. And so I'm going to go back to the handouts we have here. So I want to go over this exercise, like a small quick exercise with you guys. Go over this with you. So whenever there are 2 populations, you would have to ask yourself 2 questions. There are 2 questions we're going to ask. The first question is, okay, so whenever we are dealing with, I'm going to highlight it out. We're dealing with the mean problems based on 2 populations. Okay, so we have to ask ourselves 2 questions. So the first question we're going to ask is, we have to distinguish it. Is it going to be a 2-sample test? It could be a z-test, it could be a t-test, or it's going to be a paired test. Okay, so once you know that, you can move on to question 2, right? You're going to move on to question 2. But before that, we have to distinguish is this a 2-sample test or pair test? So for 2-sample test, that means, do you remember anything I said in the in the slides, or what do I say about 2-sample test? So what do I say about those samples? So the samples cannot be paired, right? I guess it's going to be not paired. So what do I call those samples?
Are they independent?
They are independent. Excellent. I'm going to write down here. So they are independent. Independent, that's the key. Okay. So we are comparing independent samples with matched. Some other people call it paired samples. So this is what we are trying to distinguish. Okay. So do you remember any way to tell whether this is an independent or is a matched or paired sample? How do we tell? Maybe there are some clues that you learned or anything that you remember from the videos or maybe the slides. I'm gonna write it down here. How do we tell whether it's an independent or maybe a paired? How do we tell? So first thing I'm gonna write it out here. So there are two samples, right? Okay, so you're probably gonna have two samples. We are dealing with two populations. For each population, you're gonna draw one sample. So you're gonna have sample one. You're also gonna have sample two here. Okay, so whenever we go out there and collect sample and then we collect, say, 10 observations from the first sample. And then we collect 12 observations from the second sample. Okay, I'm gonna write it down here. So what does it say about N1 and N2? So N1 is 10 and N2 is 12, right? If that's the case, can I make any inference about whether this is independent or is a matched sample?
It's independent because the sample sizes are different.
Are different. You have two different samples. So most likely, I wouldn't say 100% of the time. So most likely, they are gonna be independent samples. Okay, so independent sample, one key to notice that is you have two different samples. Okay, two different sample sizes. Okay, hold on a second, I'm gonna erase. Not equal to N2, right? Okay, so that's the one key. One very important observation. Okay, and anything else that you can say about the independent or maybe the paired sample? Anyone wants to give it a try? How do we tell? How do we tell? Okay, for example, if we are comparing mileage of two different brands of car, for example, Toyota versus Ford. Okay, so Toyota versus Ford. Okay, and so what you do is you collect 10 Toyota cars from Toyota car dealership, and you collect 12 Ford cars from the Ford dealership. Okay, so for each car, it's gonna be either in the sample one or sample two. It's not possible for any car to be both Toyota and Ford, right? That's not possible. What kind of car is that gonna be? Toyota? Well, anyway, it's not gonna happen. Each car has to be either Toyota or Ford. Okay, so if that's the study you are working on, is it gonna be independent or is it gonna be a paired sample?
Independent.
Independent. Amy said independent. Why do you say independent then?
Well, because each thing can only be one of the two categories.
Exactly. Very, very good. Because each observation, each item from one sample do not appear in other sample, right? So each observation only occurs once in one of the two samples. Okay, so each observation only occurs once in one of the two samples because a car that's a Ford has to come from the Ford dealership. It will not appear in the Toyota dealership, right? So there's some keys for you to remember to notice it is an independent sample. Okay, on the other hand side, you could also have a paired sample. Okay, you could have a paired sample. For example, if we are talking about, could any of you give me an example of a paired sample? Maybe you remember some example we did in the slides, or maybe you have already started working on assignments. Have you thought about, can you give me an example for paired sample? Anybody wants to give a try?
An example would be, so like if there's a test between different cholesterol levels in like different years, like
Yes.
We're still looking at like the cholesterol levels, but it's with different time periods.
Different time periods. Are we talking about the cholesterol level of one individual across two different time periods, right?
Mm-hmm.
Okay, so excellent. So you can see I'm gonna go to each individual and collect the two observations. So maybe the first cholesterol level 5 years ago, and then the cholesterol level of this year, right? So you can see I'm collecting the I'm collecting information from the same individual, even though it's across time, right? It's across time. But the observations from the first observation versus the second observation, they are related. Why they are related? Could you tell me why are they related?
Well, they're related because they're using the same person.
They're using the same person,
time.
right? It is the same person. They're highly related. That's excellent. That's excellent. Okay, so I'm going to write it out down here first, and then I'm going to go to Rachel's question, right? Okay, so let me write it out here. So for the pair sample, okay, so each item, each object, or maybe each observation provides one data point for method 1, and then another data point for method 2. Okay, so I'm going to write down here. So each item provides one data point for the first method. For example, the Amy's case is going to be the cholesterol level previously, maybe 5 years ago, for method 1, and another value for method 2, another point for method 2. Right? Okay. So for example, I'm going to give you another example. For example, we are comparing the mileage of a car from Toyota, right? From Toyota. You can say, before I do this maintenance for my car, what is the mileage? I don't think that's going to help a lot. Maybe okay. Let me think about it. Maybe the price. Okay, for example, before I do the maintenance, what's the selling value of my car versus after doing this maintenance, what's the selling value of my car? So you can see I'm always focused on the same car, but I'm giving them 2 different treatments or 2 different methods. So it's gonna be before doing the maintenance or maybe after doing the maintenance, right? So there's a clear comparison here. I'm having 2 methods. The first one is before the maintenance, and second one is after maintenance. Okay, give me a second. I'm gonna see Rachel's question here. Okay, but she said, I'm not sure how to explain it, but they are kind of.
It's okay, I don't have the question anymore.
Okay, is it clear now?
Yeah.
Okay, if the object cannot be counted in both samples, okay. And okay, so this is some way to distinguish independent and paired, versus paired samples. I've seen a lot of students who have difficulty with paired, and so one key for you to realize is whenever you're working on paired sample, majority of the time, I would say 90% of the time, so you're gonna see there are gonna be N1 here, and it's also going to be equal to N2. So they are absolutely the same. Okay, for some cases of independent samples, even if N1 and N2, they are the same, it doesn't mean you have a paired sample, right? Okay, so if it's a paired sample, that means N1 is equal to N2. But on the other hand side, if you have N1 equals to N2, it doesn't mean 100% of the time it's gonna be paired sample. It could also be independent, because for independent, N1, it could also equal to N2. Okay, so maybe I'm not very clear here. I'm gonna write down here 2 different sample sizes, but it doesn't have to be always the case. N1 could be the same, could be equal to N2 as well. It's possible. You can have, for example, the car dealership I had here, you could well have 10 here as well. You could go into the Ford dealership and collect 10 cars as well. You could go to the Toyota, collect 12, and then there's a 12 here. When N1 equals to N2, it doesn't mean it has to be paired. It could also be independent. It really depends on the situation you're working on, right? Okay, for the car example, each car can only be either Ford and Toyota, so it cannot occur twice in both of the samples, right? Cannot occur in both of the samples. Is this part clear? Or if you have any question, feel free to send it through chat. I would be more than happy to answer it, right? Okay, if not, okay, so this actually helps us to solve the first question. So is it a 2 sample test or is it a pair test? Once we are able to determine that, okay, so we're gonna move on to question 2. Question 2 is only relevant if it's a 2 sample test. Okay, so that means if you know it's a pair test, if you have already know it's a pair test, okay, if you know it's a pair test, this always give you a paired t-test. It's always a paired t-test. Okay, it's always a paired t-test. And the reason is because to differentiate t-test versus a z-test, the key is to see whether the population standard deviation is given. So most of the cases, population standard deviation is not a given because you have to go out there and collect sample. You can easily calculate the sample information, including the sample standard deviation, because you only have the sample standard deviation. So that's gonna be a t-test, right? It's going to be a paired t-test. Okay, just say if it's a two sample test or maybe independent test. Okay, so the second question we would have to ask ourselves is this a z-test or is it a t-test? So is it going to be a two sample z-test or is it going to be a two sample t-test? Okay, so you probably have seen there's a screenshot here. This is the same as what you guys see here in the formula tables here. It's the same. I think it's the one I copied from the last page. It's the same. All the formulas are given here. Okay, so you don't have to memorize them. Certainly you will have to know how to rate them, right? How to know what is a D0 and how to determine those. Those are important stuff. Okay. And so the key, do any of you wants to try? How do I tell whether it's a two sample t-test or it's going to be a two sample z-test? How do I tell? This is something that you guys have already seen before, right? How to tell?
Isn't it whether or not you're given the population standard deviation?
Yes, absolutely. That's absolutely correct. Okay, so let's see. So well, so the first one, what we have here is one population. As you can see here, one population. So there's only mu here. In contrast, for two population, you're gonna have mu1 and mu2, right? If it's one population, all you need to care about here is whether the population standard deviation is given or not. If it's given, that's a z-test. If it's not, that's a t-test, right? Okay, for two populations, the key also relies on whether the population standard deviations are given or not. Over here, we're gonna have a plural form because we have two populations. So if both of the population standard deviations, that means sigma 1 and sigma 2, they are all given to us. That's over here, as you can see, it's a z-test. I'm gonna write down here. This is a two sample z-test. So two sample z-test. Okay. If on the other hand side, if any of those population standard deviation is missing, is not given to us, that's going to be a t-test, right? It's just a little bit complicated. So the calculation of the test statistic, whether it's a z-score, it's a t-score, this part is straightforward. You just have to plug them into the formula. You can use Excel stat to do it as well. This part is easy. What is a little bit tricky here is finding the degrees of freedom. So you guys can see, there's a big chunk of formula here. And once you plug them into that, you have to always remember to round it down. Okay, so round down means, for example, if you get 27.99 as your degrees of freedom, you would have to round it down to 27. Because typically when you round, that's going to be 28 because 9 is a more than 5, more than 4, so you typically round up. But this specifically requires us to round down. So even though it's so close to 28, we are going to round it to 27, right? Okay, so it's a little bit tricky, just complicated here, but not tricky at all. I would promise you that in the final exam, you are not required to do such complicated calculation. No, you are not. So typically the question will give you, assume the degrees of freedom is this, is blah, blah, you're going to use that one. I remember there was one quiz question which asked you to do this calculation. There may be some single assignment question ask you to do this, but majority of the time I will not ask my students to do it. It's just very tedious. I don't think there's much point of learning how to do them, algebra. Okay, but if you did watch my video, you probably remember there's a way to check whether your calculation is correct or not, because there's a lot of numbers going on here, right? How do I check to make sure my degrees of freedom, this formula has been, used properly, whether I plugged in the numbers correctly? Do you remember there's a rule of thumb I told you guys in the slides? How do you check? Do any of you remember?
N1 minus 1 and N2 minus 2.
Oh.
I mean N2 minus 1.
Yes. Yes. Okay. So typically, after you calculate the degrees of freedom, what you need to do is you do want to check to be sure the degrees of freedom is okay. So I don't think I should use this. Okay, I'm gonna rewrite it. It's not gonna be approximate. So as long as the degrees of freedom you calculated here is not too different. Is not too different from the sum of n1 minus 1 plus n2 minus 2, then that means you are on the right track. Okay, if your calculated degrees of freedom to be 1, and this sum happens to be 20, then maybe your calculation is not right. So this is some way for you to check to make sure you know, I know this is a complicated calculation, make sure your calculation is right. Okay, I'm gonna remind you guys because I've seen a lot of students making mistakes. Okay, so one thing I want to let you know is for whenever you're calculating this equation, right? Okay, so I've seen students making mistake because you have to square it first, and then you have to square it here again. You have to square it here and here and here. I've seen a lot of students making mistake. You know, what I would recommend you to do is break down this calculation into different parts. Calculate the numerator first, then the first part of the denominator, the second part of the denominator. Write it on piece of paper. So this is going to be super helpful, right? Okay, you want to break the big task, very complicated task into smaller one. Try to accomplish each one, right?